Hello Earth Science students. Welcome to our adventures of learning Earth Science from home. Today we're going to be learning about streams, running water, stream erosion, and deposition. Here we have an example of running water. Running water is the most dominant agent of erosion on Earth. It changes the landscape more than any other agent of erosion. Here we see this running water is coming right out from the culvert underneath my driveway. If we were in a larger landscape, we might see streams and rivers. So those are the best examples of running water. The water that we see in a stream comes from either runoff, which happens when we have precipitation on the ground, or it often comes from snow melt, which is also common this time of year.
Well, you could keep going and then we just splice it back in.
Streams carry different size sediment particles. If you look at the bottom of a stream, you'll see that there's all kinds of different rocks that it carries along. These particular rocks that I picked up are the size of pebbles. Now you're going to see in your reference table that we can tell what size a pebble is versus sand versus cobbles and boulders. But these are all pebble size. When you look at the individual pebbles, you'll notice that they're pretty rounded in shape. That's because the stream bounces them along the bottom of the stream bed. And so they have a process of abrasion that's called weathering, which means they get the sharp edges of them ground off and they get to be a smooth shape. That's that. Streams carry different size sediments, as I said, and we can see the different size sediment actually tells us something about the velocity of the water. Now here, I just picked up some of the different size pebbles that are carried by this particular stream. And we're going to look at our reference table later on and say, how fast does the water in the stream have to be flowing to roll along a pebble that size versus how fast does it have to be flowing to roll around something like that or something even smaller. The faster the stream is moving, the bigger the size particle it can carry. When a stream slows down, it drops off the biggest particles and they settle right on the bottom of the stream and they just carry along the smaller particles. Then when the stream water gets fast again, when the velocity picks up, the water's going to pick up some of those bigger particles and carry those particles farther downstream. So what happens is the size particle depends on how fast the water is moving. What can make the water move faster? Well, one thing is, if there's been a big, let's say a big rainfall, and there's a lot of runoff, that means it's carrying a larger volume of water. That's called stream discharge. We get a big stream discharge after big storm events. We get it at the end of the winter when there's big snow melt. What else can make it travel faster? Well, right here you see we have a little bit steeper slope. When there's a steeper slope or a higher gradient, we call that a higher gradient or steeper slope, then the stream is moving faster. So it also can pick up and carry larger size particles. Here I want to talk to you a little bit about the stages of stream development. Now, normally when you talk about stages of stream development, you wouldn't be just in front of one stream. You would look at different kinds of streams, different kinds of rivers. So you might, for instance, find a youthful river. Youthful rivers are, let's look right here. Youthful rivers have a straight channel. So right in here, this looks like a straight channel. If we were pretending this were a youthful river, we might see this kind of straight channel higher up in the mountains. And it wouldn't be carrying very much volume of water. Young streams, that would be called a youthful stream or a young stream. Young streams also have waterfalls. Look over there, we can pretend that that's a waterfall right there. So if you saw a youthful stream with a waterfall, that's telling you that stream has not been in existence for many years. The biggest waterfalls that you guys might ever see, the biggest one I've ever seen, is at Niagara Falls. Niagara Falls is at a river that's a young river. it has a lot of water in it, but that's because it was left over from all the glaciers that melted that covered North America. But because it has a waterfall, we know that that is a youthful stream. All right, here I'm trying to show you something that would be a feature of an old age stream. Old age streams have lots of bends or meanders. As the stream is traveling over flat ground, like the whole Mississippi River Valley, the Mississippi River has many bends like that. And that's telling you that it's an old stream. Now, if you look at the bends in the river, you'll notice that there's different things happening on either side of that bend or that meander. On the outside, like here, the water will be moving faster, and so it erodes more. It's taking away, it's carrying away the particles. On the inside of bends, the water slows down and it deposits. So we have a different kind of feature. Erosional, where the water is moving faster on the outside, and deposition, where it's moving slower on the inside. So you may ask, what happens to all of this running water? So here's the running water in my drainage ditch next to my house. And that running water goes downhill. Running water always goes downhill. Now eventually that running water downhill enters into the Owlkill Creek, which is over there. And then that Owlkill Creek flows south, and then it eventually empties into the Hoosic River. So that means the Owlkill Creek is called a tributary of the Hoosic River. Any smaller stream that empties into a bigger one is called a tributary. Well, how about the Hoosic River? Is that a tributary of anything? Yes, it is, because it empties into the Hudson River. Well, what does the Hudson River do? The Hudson River flows south all the way to the Atlantic Ocean. So that the rivers, no matter what river we're talking about on Earth, it always empties into another river, and then that river will eventually empty into the sea or the ocean or a big gulf. And what happens there? It makes its final depositional feature that's called a delta. If you look on a map, which I hope you do today, look online, find a map of the Mississippi River Delta, and you'll see it looks like a giant bird's foot of sediment. It's all the sediment that's deposited when the stream slows down and leaves out its final deposition. So boys and girls, we've learned a lot about streams and running water. The final thing I want to talk to you about is this concept called a watershed. A watershed just means all the area that a stream or running water empties into. So this area right here is a watershed of my little drainage ditch. This area all here is a watershed of the Owlkill. And this really big area is part of the watershed of the Hoosic. And then the Hudson River is even a bigger watershed. Even the Adirondacks are part of the Hudson River watershed. So that's it for today for stream, running water, erosion, deposition. See you next time on our next adventure. One of the questions we talked about is how fast does a stream have to be moving in order to carry a certain size sediment particle? Here I have page 6 of our reference table. Top right says relationship of transported particle size to water velocity. And we see it goes from smallest particles, clay, all the way up to biggest particles are called boulders. Well, here's a sediment size rock that I picked out of a stream. What do we call this size particle? Well, let's measure it. That's the only way we're going to know. So if I measure it with my centimeter size of the ruler, I see it's about 5 centimeters by close to 5 centimeters. So 5 centimeters. So now I'm going to look on here and I'll see that 5 centimeters falls between 0.2 and 6.4. If I look on this side, I can also see 1, 2, 3, 4, 5. So 5 centimeters is a large size pebble. The biggest size pebble would be 6.4 centimeters. So this is a large size pebble. So we want to say, well, how fast does the stream have to be moving in order to pick up this pebble and move it along the bottom of the stream? Here's how you do it. You take your ruler, you find where 5 centimeters is. So let's see, 1, 2, 3, 4, 5. So we'll say 5 centimeters. We look at where that line intersects this curve here. And then we drop that. We drop down another line. And we'll see that where 5 centimeters intersected that curve, we go down now and we see on the x-axis the stream velocity in centimeters per second is 200 centimeters per second. That's a measure of how fast the stream would have to be flowing in order to pick up a particle size that's that big. We can see by the way this works that streams have to flow faster and faster to pick up bigger size particles. Streams can move very slowly and still carry along small size particles like clay, silt, and sand. There you go. So you guys try it out with your reference table. See if you can come up with the same kind of information. At this time of everything being different, school closure, COVID-19 worries, all kinds of things about how long are we going to be learning from home, how long is it going to be before we get back to seeing our friends and having everything returned. We just got to take it the best way that we can. So I'm going to say right now, Bill Nye, Science Guy, take a break. Because right now we've got the Grand Kenyon coming in and taking over. So here we go. Ladies and gentlemen, boys and girls, first of all, I want you to always think about it's a nice day. Don't take it for granted. Don't just stay inside and play video games. Get outside. See what you can learn about your own environment. Enjoy the flowers. Enjoy the fresh air. Whoops! And lastly, here, Google Classroom is where you want to be. Make sure you go to Google Classroom every day, see what your teachers are expecting from you, and see what you can show them that you've learned. Bye-bye, boys and girls. This is the Grand Kenyon signing off for now. Till our next adventure.